Thank you. Appreciate the opportunity to come and speak here today. Again, as I mentioned, I'm with DGT Associates. I'm actually a subsurface utility mapping guy. I've been doing this for 35 years, and a few more years and I might get good at it. But we have a little different twist in the story about subsurface mapping because we believe the history is often forgotten. A lot of people think this is a new emerging thing, but it's really not. It's been around a long time. So just a little bit of history. Our office is in the Boston area, and there's a lot of history in what we do in that area. So for example, you know about the Boston Tea Party, Paul Revere ride, and but we've had a lot of tragedies over the years. There's one that most people don't know about is the big Boston fire in 1872. It burnt the entire financial district like Chicago and other places. We've had some unique accidents like the big molasses where they drowned people in molasses when a tank burst up there. So there was a lot of unusual things happen in the area. But for me, one of the things, we have a lot of history, and especially in the academic area, one of the oldest schools in Boston is Boston Latin, 1635. So we work in a lot of different universities and college campuses and schools. And so it's 1635 is pretty old in US terms. And we're very proud of that because there was a lot of our forefathers, for example, Sam Adams, Benjamin Franklin, John Hancock, they were all alumni from the school. And my daughters went to the school, so we're very proud of that fact. And we always reinforce that, high school, that was very important because they were the best 15 years of my life. So it was really great that they spent it somewhere there. But for us, the history is one thing, but what we found from the Boston area, if you go back into the archives, it's got a lot more richer history than a lot of other places. And so we like to dig that out and share some of that history. So when you're looking at some of the infrastructure and that, they had mega projects back in the 1800s. We got utilities that were put in the early 1800s. And when you go back into these files, these are 1894, these ones on the right. These are survey engineering projects that were mega projects building the infrastructure that we rely on to this day in the area. And during that, there was a lot of existing condition surveys. There was utility surveys done. What's really important, because this is 1900 in these two photographs, and then by the time you run into 1910, 1920s, you're looking at as-built utilities. So we talk about the mistakes and the challenges that we face today. Maybe if they'd learned and kept the best practices from back then, we wouldn't be getting in so much trouble trying to build utility atlases. And it wasn't that they were just good about getting out there and doing the work. The documents they did were spectacular. So for us, this is a document that was done in 1894. It's an underground utility plan. They survey every joint, all the underground tanks, which is where they stored water for the fire protection. They even served abandoned utilities. And you find these documents, they were spectacular what they did. You get these drawings that have survey measurements and swing ties, and they're all survey accurate. When we actually go in there and survey these projects, this turns out to be highly reliable. And some of these, this is the city of Cambridge. And inside in their records, not only there were fantastic drawings, they were survey-based, they had elevations that I can still use today, and I XREF these documents in, but these were done with watercolors. So the attention to detail that we think we have today was actually there a long time ago. We just forgot to be really good. And this is one I particularly like. This is an intersection in downtown from 1895, I believe. And what you have here is color-coded drawings that shows subway system below. They survey every pipe. We went out and we did a laser scan, and all of these structures in exactly the right place when you look at these. So we take a lot of that history, we use that information, and so we said there was a roadmap for doing this properly over the years, and we try to keep that tradition. So what we talk about today in our work is how do we provide an end solution for organizations that have a higher education campus. And this is one of my projects. This is a pretty old one. And so what we do is we've combined the best of survey and we combine it with the underground utility infrastructure that's highly accurate, but providing you with solutions how you can actually map the underground and put it into something that's usable for facility people. And the reason we see this as being important is I get to travel around and work with organizations. I see succession planning as a big part of the issues. So as people leave, they leave with that legacy information. So how do you transition out from something that's a legacy information knowledge from your facility team and transfer over into a digital world? And so some of the things we're going to talk about today are going to help show and give you a path for solving the problems. So two of the things that we come across all the time is the emergency issues that come across. So we're seeing natural disasters as being a big, big problem, and that's becoming more prevalent. This, for example, is synonymous with an accident that we had with one of the customers we talked to. They couldn't find a catch basin, it was just full of leaves. and that water kept on going through their enormous heavy rains, and it actually went straight into one of the electrical systems, poured down through all the vents, ruined all the electric system. The building was out for about 3-4 months while they fixed and repaired everything. So even a single thing like a catch basin can be a big problem. And this was actually a project we were walking, doing a site visit, and we come across these emergency situations. So how do you provide your people on site with something that's highly reliable, highly accurate, and help them solve these emergency problems that come up? So, and we believe a subsurface utility map that's done properly can do that. So the other challenge we come across all the time is aging infrastructure. Again, we look at history in Boston. They had aging infrastructure issues back in the 1870s, 1880s. This has a pipe, actually, that was a litigation case we were working on that's had abandoned utilities in 1834. So the history is out there, and even though you may not have utilities that are old, we find that there's a huge issue with doing that. So trying to collect all this information, if we do our job really well, we'll carry a lot of attributes. You'll find that infrastructure where we can build up an information where you can do a risk analysis. And that information becomes very powerful as you go down the road. If you're doing beautification, paving projects, you'd rather fix those things before you actually invest in other projects. So as we work and we talk a lot of the places, one of the challenges comes up all the time is where's all that information gone? Where is it going? How has it been? And one of the things we always come across, and there's better studies done in the UK on some of the topics we deal with in our industry, and that plans alone are not good enough. When it has those emergency situations, legacy information is great, but where is it? The guy's at home, he's not available, he's on vacation. So, and plans are not good enough to just run out, open up the plans and think you're going to solve all your problems with that. So this quote is from an organization, HSG in the UK, and it says, forget about using plans. You need to do a lot more investigation to get your data in the right place. And as we travel and work and talk about organizations and see their challenges, what we're left with is various types of documents. So this is an old topographic plan. Again, facility guys don't often use it. There's no attribution and no data behind any of this utility line work. And this is my project in the University of Sydney. They have the same challenges. A lot of their digital documents replaced the older plans. It didn't carry anything that they need. And typically all of this information was anyway pushed into these back rooms and libraries, and we haven't even seen this, and it's very hard to find that data. So for me, when we look at our work, the things I need to do a really good job is to capture this before it disappears. A lot of the facility guys, we know people that have their own plans and records, they keep them under the desk, they don't want to share them. So as succession planning stories come up, we really like to capture and suck all this information in just because we know we can make a better product. So it's not just about new technologies. We like to look back at the past and say there was some good data back there and we'd like to capture it. So when it comes to the campuses, I find a lot of this was in North Carolina. These type of plans don't really get adopted by facility guys. They're good for AEC customers. They're design documents, maybe they're an as-built documents, but they don't often have details and good information for building future GIS or facility planning. And what we find a lot of times when I travel, this one I spend 2 days on the couch because when I went to a project, they gave me 900 drawings to go through. And my wife was furious when we got to the hotel and what we had. It was in a bottle of champagne. I had 900 drawings to sift through. So this capturing is really important, but it's often overlooked. And you'd think that would be an easy thing to do, and it's really not. So it probably is hard to see from the back. But this is a project in St. Louis. This is Children's Hospital. And the people that were working on this, I got 2 weeks to sort this mess out because there was a firm, a big design firm, had done it for 5 years, and they screwed it up completely. And it may look similar, but what you actually do is they had 2 different water lines, both were wrong. 2 different telephone lines, both were wrong. The electric was wrong, the steam was missing, and all the underground tanks were not on there. So just because it's a big firm with a big retainer doesn't mean that you're going to capture the data accurately, completely, and be able to put it onto drawings. So a lot of the issues that come up with utilities, a lot of people think in this community, we're thinking more about asset management, facility management, doing 3D models. But the big part of our industry is also in the damage prevention. Again, we look at history in Boston. This is from 1897 when they were doing the thing. Most people think the big rivalry in Boston was Yankees and Red Sox, and it wasn't. The first rivalry was in the 1800s to build a subway system. During that time, they actually made a mistake. A contractor hit a gas line, and they killed 6 people. So it's the first documented disaster for a contractor breaking a gas line I've ever found any place I work in the world. And so we actually have presented this. It'll present later in the year in Amsterdam and in maybe Australia, but it's a story worth telling because there's a lot of lessons learned can be taken from these old documents. When I look at the underground damage prevention issue, most people don't really see it. It's like a car crash. That information doesn't get disseminated across state lines. So this was an idiot engineer I worked for. I worked for him many years. He called me, had an emergency, and I showed up, and this is what I saw. And this guy drilled into a water pipe. He said it was only one utility. He didn't call one call. He said, what was the chance of hitting it? And he did. He broke it. But what's more important is when you have a tragic accident like this. This is Walnut Creek, California, 2004. The reason this one is so important is the entire team thought that by having notes and plans in the drawing, by doing risk transfer in the specifications, you transfer the risk to the contractor. So when he broke that line and he killed 5 people in that trench and 2 died later on, they thought there was no more responsibility. And they found that the core precedent didn't see it like that. So the core precedent for this accident says the owner's liable, the survey firm, the engineering firm, the contract locator firm were all responsible. So this shows that you cannot just say, I'm doing a risk transfer of my documents and notes and that little logo for A11 will help you out. That's not the case. The other interesting fact is I work with Common Ground Alliance. I do a lot of writing for them. They're kind of a construction manual. And so they're published all over the world, which means my magazines are in bathrooms all over the globe, which is great. But the document says that in a study they did, 17% of all accidents that recorded were attributed to inaccurate locating practices that amounted to $136 billion. So it's not a small thing. This is an iceberg that's out there. So locating and mapping utilities is important in damage prevention. And there's a few other things. American Public Works believes that there's an accident every 60 seconds in the United States. So again, it's very hard to document because there's nobody really reporting every accident. The other issue I always talk about is for especially organizations like this. When you have facilities and you go out there, every single project has an environmental investigation. They do a geotech investigation for project, but they often forget to do a subsurface utility investigation. And this is not really an option. This is a huge exposure for everybody. So when they go into a campus, you have very little help finding out where utilities are. So I always caution people before they start boring, you need to do an extra level of risk management before you look at these services. Now this is a part of the CFR. I'm not sure anybody here, I'm sure this group knows a lot about the CFR. But I often work in construction groups doing seminars. I get asked to come there once, but never twice. And the reason being is I go in there and it's the Springer Spaniel story, where you ask them if they know what CFR 1926.651 Part B is. And they go, not a clue. They go shaking their head, Springer Spaniel, never heard of it, didn't want to know about it. But yet the section before this is about trench safety. Section after this is about confined space entry. So they know that part, they choose not to do this part. And this part says, in addition to doing all that work, in addition to your consultants designing a new building and doing a site plan and having all that done, the contractor is responsible in this section to bring a locator and protect the workers and the public from an accident. So they always blame you guys. Your consultant did a bad job. There was nothing on the print and the drawing. Not my fault, I broke a line. That's not true. So this is the part of the CFR that OSHA uses to go back in and say, you're an idiot, you broke the line, it's partly your fault, and stop blaming everybody else. So it's a very important thing to remember. So the reason we have a few videos here is not to make fun of my English colleagues, but it is very important. And the reason being is I'm going to show this video again, right? So this is the village idiot in the big village, right? So when you look out the window on a job site and you see a guy in a high-vis, you expect that guy to have a knowledge and be able to do his job appropriately, make good decisions. So when you look at these accidents, the gas line accidents, you trust that that person's going to make a good decision on your part? Did you trust that guy that he made an informed decision before he got out of his $50,000 truck and did nothing to get a $1,000 locator to go out and check utilities? So village idiot here risked these pedestrians' lives. I'm going to show that again, not just because he's English, because they do it everywhere, right? But his plan A, when the shit hit the fan, was to go out there with a trash can and throw it on top of a water line. Like, what was he thinking? So you can imagine if this was a gas line at an air intake on a college campus, that would have been a different story. So we're absolutely furious that people find this still exists today. So we're always very cognizant. The other one that I show is a little bit more serious, and this is a training video from the UK as well. So the difference between what we talk about is it's not just a line on that topo plan. For us, that line is very important, right? You can plot that line, you show it on a drawing, and you say, but what's really important is how accurate it is. Because that poor bastard had to make a decision. He almost ended his life. So for us, we take it very personal that if we put a line in a drawing, that we give him the best chance at life. And so it's not fair to him or his family. So I'm absolutely furious that the industries do this. So when he made a decision, he wouldn't do that intention. If we did a good drawing, we present a good drawing, we go out there and show him exactly where everything is. And I think that's our responsibility in the design and the construction and OEM phase of projects, to go out there and share that information. Now, there's a social and economic impact to this, but we have a saying, it's a technology term in Ireland, you can't fix stupid, right? And stupid comes into terms when people keep on making mistakes. And so these are some projects that are, they're not campuses, but it's spectacular in the numbers. So far right, 405 in California. I know Gabriel probably knows this one very well. But what happens here is they had a $500 million claim for undocumented utilities. They went into construction and they were completely stupid. They were not aware of all of the impacts they had. They're currently doing a project that went from $60 million utility issues in the light rail in California, and now it's already spiraled to $390 million. So the numbers are spectacular. And I had the opportunity to work on this project in Sydney, and again, you can't fix stupid. It was a $1.6 billion job, and it's now a $3 billion project, and it's all attributed to undocumented utilities. So it's a very serious issue. So you go back in Winston Churchill, if you fail to learn from history, you're condemned to repeat the same mistakes. So what we're saying is that if you take a look at this, you stand back, and it's not just about paint on the ground, there's a little bit more to the story here. And so one of the things we always work on is avoiding the misconception that 811 is going to help. Yes, it's important. Yes, it's state and federal law. It's in every single state, and it's wonderful. But you cannot rely on it. It is not all-encompassing. So if you look at the states, they all have the same thing. There's generally all the same kind of laws, the same regulations, pre-marking. But what you don't know is that there's only 65% of utilities in America are actually privately owned. Inside in the other portion of that, there's a lot of people that don't participate. So if you're trusting them to come out and mark the lines, you're very much mistaken. You're probably not even getting half of the utility you need, and on the private property, you're probably not even getting 10%. So it's a big issue. And to prove that, it's not just throwing statistics or scare tactics. This is a project again in St. Louis. This is my CAD drawing. Delivery, it's a $100 million building going in here. This is my CAD drawing with all our American Public Works color scheme on here. This is the gas company plant. What you notice is there's no gas line here, here, or across the top. So knowing that, when you look at it, and right there, 20-inch gas pipe, that's a 6-inch gas pipe, they would never have known about it. Nobody's marking out for dig safe. That is a monster pipe right next to where you're going to be doing excavation and foundation elements. So when we do our 3D model and work for the clients and they say, well, why is your retainer expensive? I don't think we're that expensive. Accents are expensive. Paying for people's lives is expensive. So when we do our model, you can see our gas line is right in here. Those pink marks are where they took a vac truck and verified. And the reason being is some utility owners remove that information from their drawings to reduce their tax burden. If it's not on the drawings, they have less of a tax burden. That's a real problem for people like you, because if you're relying on consultants to just combine drawings, to digitize it, suck it, put it in together, you don't actually capture that information. So without a subsurface investigation, you're not going to get what you need. I fight stupid every day at work. And problem is because people don't realize the difference between apples to apples comparison. So some people, this was actually from California, this is San Francisco, somebody got doing that. And so what you have is a lot of people interpret what the subsurface mapping project is. And so we try to do a lot of education writing. So when you go, okay, where does our history come and how does this play in? Well, for us, my VP back in the day was a part of the standard. This is the American Society of Civil Engineers 3802 guideline. It's not a law except in Pennsylvania and in Colorado. The reason this is so important is we already knew how to survey. But when we depict this underground infrastructure, it's not just a line on a drawing. We want to add an attribute that says how reliable is that information. So, and that's a part of the next few slides. I'm going to explain how this works. So this is all of this put together into solving those problems. So this is a college campus that we're doing a new building. We got brought in by the the university because they said the design team really didn't have a good as-built of all the existing utilities. So what we were looking at is we did a Lidar scan through all the underground tunnels in the vicinity of the project. This is a terrestrial scanner, not a GeoSlam or mobile unit, because this is like 7, 8 years old. This is pretty old stuff, but it's still a good video for presenting. We went through all the mechanical rooms, all the connection points that we're trying to protect. And then on the surface, we did the Lidar scans to capture the existing site condition. And that's really important for me because if anything happens, I want to be able to document what that site looked like the time I did the survey. So what you're looking at is we stitched all the scans together. We actually did more. We did inside the building as well, but there's too many to make a video on that. And what you're looking at here is we modeled in Civil 3D, we modeled all that underground infrastructure. Level of accuracy is less than a foot for all that infrastructure. After 35 years, I get 0 calls, 0 callbacks saying you missed something, it's not done right. And typically, because we know how to do this, there's a whole role to doing that. And that's not that we're unique, but if you follow the program that we do, these are the expectations you could have for reliable work. So the reason the standards are so important, it's not just a bunch of engineers getting together in the US going, that's a great idea. The rest of the world has believed that this is fantastic. Not only this, so we have 3802. The only thing smaller than this is than this book is Irish Sports Stars. There's nothing smaller. It's a very small book. We're not asking you to read the Old and New Testament. We're literally asking you to look at this document and see what's in there is valuable information. And this was 2002, it was released, and it's still the same version today. Canadians followed us, and this is CAS in 250. Australian 5488 came out, exact same document, very few changes. PAS 128 in the UK, same document, same thing. So we got Hong Kong, we have India just brought theirs out recently, and they're actually following the same standard. So we're not talking about something that we all came up with just to drum up sales. Everybody across the globe, including Ecuador, think this is a good idea. The downside of this is there's a lot of studies, and everybody says, yes, there's a great return of investment. But when you do studies, this was Sharp 2 research done. Penn State did it, I believe. Ray Sterling, which was a gentleman that works in our industry a lot, when they did their whole review of it, they said there's no one tool. His executive summary is all the technologies and all the geophysics out there. There's no silver bullet. There's no one tool going to solve your problems. And that's the downside. You're actually going to have to go and do the work. But that doesn't mean it's going to be tough or expensive. And the reason being, this is an old university drawing I did. This is actually Harvard University. But what we're saying, we know exactly how to put a cycle diagram together that can work. And the biggest thing we always point out is the budget will dictate what the scope of work would. That seems like a no-brainer. But what you're going to see is that we're not asking you to go out and start spending millions of dollars or hiring fancy guys coming from Boston. What we're saying is you look inside the standard and there's only 4 levels of information in here. It's A, B, C, and D. So D is a desktop survey. D is when we were looking yesterday at Zach and Sue talked about in their presentation for Austin University, is all that information they're putting together is level D. That level D is very good information. You have to start with level D. But it doesn't mean you go out and spend a lot of money in the field. So what we're saying is that if you had a database and the only thing you'd win is go back to your office and say, everything I have in my database is all level D information. So when you give that to anybody working, they know it's not verified. You can't rely on it. You have to do appropriate actions, digging holes and testing it, tracing lines to verify it. So it says, yes, it's good information, but you got to verify it. Level C information is what surveyors have done. So we try to respect what surveyors have done for a couple of 100 years. And that means if you surveyed up 2 manholes, you draw a line between those 2 lines, you make an informed decision. It says, I haven't done any underground investigation, but I've drafted a line, but you're telling the end user how reliable that information is. The next level is where we get into geophysics. That's level B. And so level B is important because that's where the truthing comes in, where you're tracing out lines. It's not just a straight line. It actually went around the tree. That's what happened in Walnut Creek. The pipe actually went around the tree. The tree was no longer there. The contractor assumed he would never hit it, and he did it. The line bent into the street. So it's very important in level B that you trace out the utilities, and that's really where that level of accuracy is getting you to within a foot. And in level A information is when you're doing that exploration or test holes where you vacuum down. But you could do it inside in pits or vaults. An open trench, for example, is still considered level A. Now, what you see off of level B is these are the handheld locators. You look at the studies done by use. This is way at the top this is the most common tool in our industry. Go ahead, sorry. 5 minutes? 5 minutes. Sounds good. I've been thrown out a lot of places, so that's okay with me. So, but what you see is these locators, they're really important because what you see right here is there's a lot of metadata that's inside in these, and that's the depth. That depth information is what I need to make the 3D model. So that's one of the places I get the Z value, and that's becoming more and more important. So, and the reason being is we don't sell paint. I don't even like buying paint. This is on the University of Sydney. Again, I'm not out there to paint it up like DigSafe. In fact, you'll never even know I was there. So our technician here, Paul, traces the line. He writes the depth, and he writes W. So we know we're tracing a line. We have all the information to survey up, but I'm not actually going to go out there and spray paint everything up. That's not what we do for a living. So we want to capture that information, but it's done through these locators. And what's changed for us that's making our business a lot sexier is cloud-based systems have come in for us as well. So these are systems, this was a trial I did in Australia a few years ago, and they've combined pipe locators with a Bluetooth device inside with a lot of the commercial GPS units. So when we talk to some of the universities or say, Zach, if you wanted to do something in the future is having a locator that's connected, so as you hit the button in the field, it's capturing that information. So that's really important for updating your database as it goes through. And over time, you'll get up to a level B, but you don't have to do it all in one go. And this is really important because all of these systems, Geolantis 360 is a cloud-based system that's owned by a very good friend of mine from Austria. And what they've designed, and this came out in Europe first and now it's across the world, is they can go in and out of GIS and CAD. It's made it very easy to export, but we're capturing the data from all that work that's done in the field, and I call that data mortality. All that paint outside, nobody's capturing it. So we like to capture that and bring it back, and so you can see that live every single day when you're doing this work. So there's ways of turning back the clock. And the reason that's so important for us is in that damage prevention, that finger pointing story that happens on site, it really actually can stop because the metadata behind this was a job in Adelaide, but when my technician was out there locating, we know the date, the time, the locator, the depth, the frequency was on working on. So we're able to mine the metadata from inside that device. If you go out on the street and you see color paint, you really don't know if it's real or not real. In the future, we do know where it is, where it came from, and who's responsible for it. So that's a big, important part for us. The other technologies that are out there, so the next few slides are just going to show all the ways. The pipe locators are great for metallic lines, but for non-metallic, we have to rely on ground-penetrating radar. This is a very good illustration from one of the vendors I use. And it's, as it passes over, it bounces back a signal. We connect this with GPS again, and again, we can track that and import the information. On a global level, if you have a massive campus, I use this with Con Edison, and we're able to put a Lidar on a helicopter, put thermal imaging on the bottom. You can probably scan any campus anywhere in the world with a system like this in a single night. And again, the benefit is some of the heat loss. So again, if you digitize this information, it becomes level B information. So it's a great way. So there's solutions for every type of project. This was a job for infrared again, but this was in Joplin, Missouri. And you wouldn't believe I was sent out there to figure out the difference between a water pipe and a sewer pipe. Now you'd think that would be a lot of overkill to have me go to Joplin, Missouri to find 2 4-inch pipes. But the idiots that built the system used the exact same pipe. They buried it side by side. And when you open them up, there's no tape or measurements on it. So you don't know which one is the water and which one is the sewer. So the difference is we can find it with GPR, but the thermal difference comes off a thermal imaging camera. So that was the way we recognized it. So other new tools that are coming into our industry that are really making our industry sexy is 3D imaging systems. So back in the day, I used to always climb into manholes. Now I'm worried I won't fit there anymore, so I have to work on a plan B. So instead, we have these really cool imaging systems where I can make a 3D model from the surface without going in and get some of the depths and the shape of that chamber. That is really important for me in the 3D model. And these are GeoSlam, this one right here, where we walk around the building and we can capture all that information. Not as good as a terrestrial scanner, but it can capture really good information quickly. Again, everything we do, we want to survey it up. So we really like to have the survey base, and it does an export to CAD or GIS. It's not that hard anymore. What's really tough is you need to work on your project and design. So everything for me is about project planning. I don't do fire truck work. I never do jobs tomorrow. And the reason I don't do that is because we need to plan these out. This is Port of Miami a couple of years ago, and when we were doing the work, when we were doing the tracing, we're building inside the data collection that this is level B. So we're exporting directly into GIS, and that data carries the attribute with it. So we carried all the pipe, the size, the information, so there's less post-processing, you're not filling out fields. We do that in the field when we do these projects properly. So that's very important. So for us, you think it's upselling, but a lot of people actually know about this. Georgia Tech, for example, have ASCE inside in their best practices since 2012. And these are just samples of some of our projects. We still do most of our work in 2D. What's really important, this is in Georgia, this university campus. Every single line on my drawing has an attribute. And it doesn't mean everything's level A, B, C, or D. There's a gas line in here, couldn't find it. I don't know if it exists, but it's level D. I'm telling everybody downstream working when they get my drawings, I found these other things, but there's something out here you need to investigate. So these drawings are very easy to do. It's just about the same price as a topo survey, so it's not beyond reach. And this is a recent one where we're getting a little bit more sophisticated with our drawings and legends and libraries. But there's nothing really too hard about these. And again, the drone becomes very important in our industry. A lot of times I don't have a base plan, so we're sending up the drones to capture this. This is exactly what our clients get from us these days. So all the different line types are labeled. Every single line on here is labeled. But it's not just labeled in the drawing. All of our layers in CAD and in GIS have attributes attached to it. So we click on a line. I'll know the difference between a level D gas line and a level B gas line. Similar, this is a recent project just last week. We sent up a drone. This client only wants to go to level C. And I use this because I can see the road scars. So I can see identification, things that are telltale signs that they're not all done. Not all utilities have been forwarding their information. And so the drone becomes very good. I can't get that off of any other imagery or GIS. I need current information, and the drone has become a very valuable tool for us on that. And of course, the future, for me, I've been working on these prototypes for years. This is a system I used in 2012. And this is where I want to drive down the roadway and stop being the guy in the middle of the road every day. It's been a very dangerous environment to work. So, and I don't believe it's fair to have us in the middle of the roadway without protection anymore. So these systems are very expensive, but I believe they're the way of the future. And the reason being is that that's radar tomography. If you want to go to a higher risk of projects, then don't do any investigation. But if you want to go to the exact opposite and say, I want to carry no risk, I want to do everything I can possibly do to find everything out, radar tomography is the way to go. And I'm going to show you why. So this is a radar scan, just like an MRI scan. And as it goes down, what's important is it's slicing, inch by inch, right off of the roadway surface. And as you go down, you get to see everything. So again, this helps with the 3D model, but if you're looking for ground tanks, all that other stuff that's not on drawings, the things that everybody has forgotten, radar tomography is probably one of the technologies. When we do this, I did a proof of concept myself about 1.5 years ago, and we got published on this, and it's building these mobile systems, so Lidar on the top, GPS and IMU for tracking the vehicle, geophysics in the back section. And what we're doing is stitching together the baseline data. So we believe in the future people are going to drive the campus, have all that information collected, because I can do about the best part of 60, 70 miles in a day. Typically, I'd rather keep it down to 20. But all this information can be amalgamated inside into GIS. You can look at all this data and do a lot of post-processing, but it gives you all the data you need to start with projects. So that's a really good information. So these are just a few technologies that are coming up and you're going to see more of. So I'm going to leave it there. I know there was a lot of slides, and thank you for your patience. But we knew there was a lot of benefits to what we're doing. So we see a lot of people doing wonderful things on the inside plant. When we come into the outside, we think there's a little bit of knowledge needs to be gained about the risks, where they are, and the technologies and how to solve the problem. So this was kind of a tip of the iceberg, and there's a lot more behind a lot of that. There's silos of looking at the locators and which one works best. So I'm always available for people if they want to call me up afterwards or chat or see what's best for them. I look at drawings for people all over the world and give them some information about what I recommend. But you know, these are some of the reasons we think this is really important, and we know that. So, you know, things like resolving, somebody says gas in the area, they don't know where it is. You can't start digging when you have that information. We know some of the old databases, when it was stitched together, was done by technicians that had no idea what they were doing. So we can resolve that. We know we're going to solve some of the problems for underground damage prevention, save people. And the big thing for us is there's a lot of this data goes mobile. And one of our partners is actually HoloLens. And he's a gentleman that's phenomenal at uploading all this data into Glassware. If you have an existing geodatabase, you can actually load it and walk out on site with HoloLens, and you can see all of that. So, and we believe that's going to be the future for many campuses. So thank you for your time today, and I think